Question 33. A crate of mass 10 kilograms is pulled up a rough incline with an initial speed of 1.5 meters per second. The pulling force is 100 newtons parallel to the incline, which makes an angle of 20 degrees with the horizontal. The coefficient of kinetic friction is 0.400, and the crate is pulled 5 meters. Part A. How much work is done by gravitational force on the crate? Part B. Determine the increase in internal energy of the crate incline system due to the friction. Part C. How much work is done by the 100 Newton force on the crate? Part D. What is the change in kinetic energy of the crate? Part E. What is the speed of the crate after being pulled 5 meters? In the problem, it is given that the mass of the crate is 10 kilograms, velocity initial of the crate is 1.5 meters per second, the pulling force parallel to the incline is 100 newtons, coefficient of kinetic friction is 0.400, and theta of the incline is 20 degrees. The problem is asking you to find, in Part A, work of the gravitational force, in Part B, the increase in internal energy, C, work done by the 100 Newton force, Part D, change in kinetic energy, and Part E, the speed of the crate after 5 meters. For Part A of the question, use the equation work equals length times mass times gravity times cosine of 90 plus theta. Now plug in the given quantities into the equation to get work equals 10 kilograms times 9.80 meters per second squared times 5 meters times cosine of 110 degrees. The answer to Part A is work equals negative 168 joules. For Part B, use the equation force equals the coefficient of kinetic friction times the normal force. Go. Since the normal force equals mg cosine theta, plug that in so you get force equals the coefficient of kinetic friction times mass times gravity times cosine of theta. Now use the equation change of internal energy equals length times force. Now substitute in the last formula for force to get change of internal energy equals length times coefficient of kinetic friction times mass times gravity times cosine of theta. Now plug in the given values to get change in internal energy equals 5 times 0.4 times 10 times 9.8 times cosine of 20 degrees. Now simplify to get change in internal energy to equal 184 joules. Now for Part C, use the equation work equals force times length. Now plug in the given values to get work equals 100 times 5. Now simplify to get work equals 500 joules. For Part D, use the equation change in kinetic energy equals the sum of work minus total internal energy. Now use the equation change in kinetic energy equals the work done by the force plus the work done by gravity minus the change in internal energy. Now plug in the values you found in the previous parts of the question to get change in kinetic energy equals 500 joules plus negative 168 joules minus 184 joules. Now simplify to get the answer of change in kinetic energy equals 148 joules. For Part E, use the equation change in kinetic energy equals 1/2 mass times velocity final squared minus 1/2 times mass times velocity initial squared. Now rearrange the equation to get velocity final equals the square root of 2 times change in kinetic energy divided by mass plus velocity initial squared. Now plug in the values you have to get velocity final equals the square root of 2 times 148 divided by 10 plus 1.5 squared. Now simplify to get the answer of velocity final equals 5.65 meters per second.